So we are officially at the hour. Am I right on my time? Because I feel like all three clocks in front of me have different times on them. Okay. So, well, welcome everybody. My name is Kirsten Angel. I'm the Associate Director of Advocacy here at NORD. I oversee our Rare Action Network program, which is our grassroots advocacy arm of NORD. And I work very closely with our wonderful volunteer state ambassadors, who I'll introduce you to momentarily from Maine. But I thought we would kick today's event off with, I have two short videos that I'd like to share. So I am going to now share my screen and play the videos for you.
I am Tristan.
Angelina.
Jag vill säga Shafik. Hej Sheila.
Habari ya asubuhi Javi. Jag är Christian och jag bor i Norge.
I live in the United States of America.
In Australia.
Malaysia. No gracias.
Tunaishi Kenya.
My passion is for fashion and design.
I love to dance.
Eu sou Rodrigo. Para viajar e descobrir novas culturas.
Anapenda kunitazama nikipuliza mapovu.
Jag älskar idrott och spela spel med familjen. Minhas paixões são minha fuga quando as coisas estão difíceis.
When your disease makes you feel isolated.
It's difficult to walk.
Och värme på lagen.
When I'm tired.
Right.
O controle da doença pode ser desafiador.
Muda muhimu sana.
But we learned to be resilient.
Para apreciar os pequenos detalhes que trazem alegria.
Nikijua anasikiza hadithi na sauti zilizo karibu.
Sua bondade inabalável.
Mashirika ya wagonjwa. Ninaweza kulikimu. I'm Angelina.
Nós somos fortes.
And we are proud.
Welcome. I'm Peter Saltonstall. Community. So thank you. The role of Rare Disease Day is to bring together advocates and patients from around the world to help tell the story about rare diseases. There are events like this happening virtually all over this country today. And some of the audiences that we're really trying to focus on are those in the state legislatures, where advocates and legislative people come together to understand the burden of rare diseases and the impacts it can have on them, and therefore build the appropriate legislation and pathway to make sure that bills are passed that support rare disease patients. As a matter of fact, NORD's doing that in a very focused way with rare disease advisory councils. We've got them set up down in 16 states and are building them in others. I think 2021 is going to be an interesting year for us. The reason I say that is because we've just come off of a very difficult year with a pandemic that's impacted the rare disease community in a number of different ways and has really shown some of the inequities in the healthcare system. For all of you that are watching today, the importance of the rare disease advisory councils is critical to the success of being able to communicate the story and the needs of the rare disease patient community. So in conclusion, I would really like to make sure that I recognize and thank all of those sponsors who have helped us make this day a reality. Without your continued support, none of this would happen. So a sincere thank you from all of us at NORD and the patient community. Taking part in events like today are really important to the rare disease community, and we must always remember that alone we are rare, and together we are strong.
Great. Okay. So now I'm going to just briefly share that we at NORD are unable to provide medical or legal advice, nor are our volunteers. So this full disclaimer will be located in the chat. Feel free to take a look at it. And also please use the chat today to ask questions, and we will address them at the end of the program. I'm now excited to introduce you to our wonderful volunteer Maine Rare Action Network Volunteer State Ambassador, Kevin Dickinson. Kevin?
Hello, my name is Kevin Dickinson. I am the Maine Volunteer State Ambassador for RAN, and I am fairly new to this role. I've only been in it a handful of months, just trying to first get my feet wet and get into the Rare Action Network as more of an advocate and leader. But I am also trying to build the organization in Maine and bring together our rare disease family here in Maine together so that we can have a voice and try to make our lives as not easier, maybe simpler, better, so that we have a chance together to understand what our barriers are, what challenges we are coming up against, and what successes we have, so that we can utilize the resources not only that NORD has, but have a chance to perhaps make an impact in legislation through perhaps a Rare Disease Advisory Council and Ardac, which we'll go into a little bit more here coming up. But I really hope to be able to serve the people of Maine and hope to hear from more of you to hopefully get involved with the process, and hopefully together we can build a better future for all of us here in this great state. And from that, I think from here, we're going to go over to Anissa, who is the policy manager for the Eastern region. And she's going to go over our state report card, and I think maybe talk about the RDACs a little bit.
Great, thank you so much, Kevin. So let's start with the problem. More than 25 million Americans are living with one of the more than 7,000 unique rare diseases. So that breaks down to about 1 in 10 Americans. Even though that may seem like a lot, state decision makers still have limited awareness of the issues and impact that rare diseases have on patients, their caregivers, and the overall healthcare system. So what is the solution? NORD believes it's to create RDACs, a diverse body to advise state government on the common obstacles that the rare disease community faces. We see this as an enormous opportunity for government officials and the rare disease community to work together to develop resources necessary to prevent and address barriers in a strategic way. There are a number of differences between each RDAC in different states. This includes the number of members on their council, varied members of the rare disease community represented on the council, differences in where the council works out of, funding, and duties and accountability mechanisms. Overall, each RDAC has the same goal of supporting the rare disease community by increasing the voice of rare disease patients and caregivers at the state level. So to date, 16 states have passed RDAC legislation, and we are also excited to report that we have several other states that have RDAC bills that are currently being heard. So as mentioned, we're really excited to have RDACs that have been implemented in several states. We really want to continue increasing that number to give as many rare disease advocates a voice in state government as possible. NORD highly encourages that different state RDACs collaborate with one another to share ideas and best practices. We continue to develop and release toolkits and one-pagers, host webinars, and convene additional meetings to support ongoing RDAC work. Great, so what is Maine's RDAC status? So at this time, Maine does not have an RDAC in place. However, we have several great advocates in this state who are passionate about rare disease advocacy. So within the next few months or so, we hope to begin building a diverse coalition to discuss what the rare disease community in Maine would like to see in a potential RDAC, and to work together to push legislation across the finish line. So if you're interested in getting involved in these efforts, then please email us at ardac@rarediseases.org. Also happy to answer any questions towards the end. So now I'm going to jump into an overview of an important tool that we use at NORD. In 2015, NORD launched its State Report Card project with the goal of evaluating how effectively states are serving people with rare diseases. So this year marks the 6th edition of the State Report Card, which was compiled using data current as of November 2020. So these are policy issues that NORD's report card focuses on. It's important to note, however, that these issues are not exhaustive. These issues touch on several critical and relevant policy areas at the state level, but with each issue included, there are still many others that are capable of impacting the lives of rare disease patients. So how do you find out where your state measures up? So you can select your state by clicking the link that is listed right there. Each state page is also available in a printable version. So these are just small snapshots of some issues that rare disease patients face, especially in 2020. Current legislation and changes that have been made so far in 2021 have not yet been captured. So if your state recently passed legislation to improve one of the policy issues, they might not have that high grade in the 6th edition. So you'll likely see it change in the 7th. So this website provides a detailed overview of the data, and you can learn more about each policy issue in the methodology section. So if you have any questions about our report card, then you can always send us an email at policy@rarediseases.org. And with that, I will turn it back over to Kevin.
Hello, thank you. That was great. I'm going to talk about my story as it pertains to the rare disease world and how I came to enter this world. And that would be through my daughter, Kenzie. Kenzie is now 6, but our journey started from birth. Much like other rare disease families, we quickly identified what challenges and barriers were presented to us, especially looking back at it in hindsight. You can see it much clearer, but Kenzie encountered a lot of developmental milestones, not reaching them by first, second year of life, and a slow progression of trying to identify what was going on with her. Doctors at first kind of pushing back, saying, you know, just wait a little bit, maybe she'll catch up, until finally genetic work started, MRI started, and a local doctor had told us in our first and misdiagnosis, unfortunately, which happens in the rare disease world quite a bit, of this is what it is. It's a mitochondrial disorder. She has Lay's disease. Not a whole lot you can do. There's some treatments we could do, but don't expect her to make it out of her single years, basically. And so we moved forward with that. I don't like always taking no for an answer or take it lying down. So I started doing a lot of research on my own, and we brought it down to Boston Children's Hospital. That is where, through full genome sequencing, finally, Kenzie was identified to have what is now known as a variant of the VPS13D gene. At the time, she was one of 6 identified in the world. She's now, I think, one of 20. At last count, there could be more. We're constantly finding more. But what we did with this was we look at first, it was as ourselves as parents coping and how do we help Kenzie? How do we get her the best health care possible and treat her symptoms? And as time has gone on, that has turned into where I am now with advocacy, because I've learned where our barriers were. At first, it was what no one told you about that. Like in Maine, you start getting care at age 3 in a pre-K setting for children with rare disorders, or any disorder really, anything that's disabling. But before age 3, you can also get treatment. But we weren't introduced then until well later on Kenzie's 3rd birthday. And the question always was, that was given to us was, how come you didn't know about this before? And that is why I'm here today, not only as an advocate, but as a Maine State Ambassador, to help all patients and families try to make sure they know those resources are available when you come into this world, either for the first time, or maybe you've been, you know, dealing with it for a while and haven't quite known what resources are available to you. With Kenzie in particular, we've used her and put her story out there so that people can see what challenges we face, such as whether it be funding or getting her the right equipment, getting even, I think a lot of people are familiar with the Katie Beckett program in Maine. If you're not, that's how children in Maine are labeled as getting disabled in secondary insurance coverage, but it's quite a process to get into it. It takes well over a year to get approved for that coverage. And you have to be denied a few times or a couple times before you can get actually approved for it. So these are types of challenges that we faced and we want to overcome. Kenzie takes it all in stride. She's very happy, outgoing, very energetic. She loves everybody and everything, and especially baseball, music. But we want to give her the best quality of life possible because we really don't know what the future holds for her. There's a lot of research being done, has been done in the past. COVID is a challenge I think we're all facing. We have faced that as a family as well in our story. It has really, we went from a lot of progress work with Kenzie and her medical procedures and even school in general, her therapies. But COVID put a full halt on all of that. And for the past year, we've kind of been, I think like a lot of families in Maine, I would imagine, just squandering a little bit. We've fallen backwards, we've regressed. We're just now starting to get medical appointments in Boston again. But at the same time, there's a light at that tunnel too of being telehealth. Telehealth has been a double-edged sword for us. It has helped in some areas, and in other areas, it's kind of, well, it's good for a couple appointments, but now we need to be seen in person. But I believe telehealth is going to be an important tool for the people of Maine, especially those in the northern counties and the western counties, to have that link to top tier healthcare without necessarily having to travel unless you absolutely have to at least be able to be seen by top doctors. And these are important avenues that have opened up for us, and I don't think those doors can be easily closed. So I think we have a lot of forward progress to make. And these are all reasons to move forward. Kenzie's story is important. There's a lot of bumps and bruises along the way, but that's how we learn. And I think from her story, we can definitely move forward. We're just now, you know, for everyone, she is doing okay. She is in a wheelchair. She's had failure to thrive a couple of years ago, but through a feeding tube placed in Boston, she's gained half that weight back. So she's a little over 40 pounds now and is finally outgrowing things. At the age of 6.5, she's outgrowing her toddler bed. And that is, you know, another classic example of a barrier in Maine is they will not approve us for a medical bed for Kenzie yet because it has a mesh wraparound around it. So they consider that a constraint when in fact it keeps her from injuring herself. So those are things as a rare disease family and world that we can work on to better, you know, why is it so challenging? You know, why do we hit these kind of bumps? But with that, I'm always glad to share Kenzie's story. There's so many pieces to it. We had so many ups and downs, and like any rare disease family, we just keep pushing forward.
Thank you, Kevin. Unfortunately, our next speaker has not been able to join us, so I'm going to actually let you introduce Dr. Zubari, Kevin, if you'd like to.
Absolutely. I'm very pleased that Dr. Zubari could join us today. He is the Technology and Research Development Scientist with Jackson Labs, which I'm proud to say is headquartered right here in our great state of Maine. And Dr. Zubari, really glad you could join us today.
Thank you, Kevin. I appreciate the introduction. And I do have a few slides, and so I'd like to throw them up on the screen. And I think, Kristen, you're still, there we are.
Are you able to share?
Yes, I'm just getting it set up. If you give me 1 second here.
Just want to make sure you're not having any tech issues.
No, we're all fine here. There we are. I think you're looking at the wrong screen, so let me switch that around. There we are. Sorry about that. Thanks again, Kevin, for the introduction. My name's Amir Zubari, and I am probably one of the first contacts that many foundations have when they call the Rare and Orphan Disease Center and they're really looking for information about making a model and generating a model. I've been a lifelong geneticist, started out with my PhD at the University of Sheffield in UK, and I've done microbial genetics research at the University of California, Davis, and studied bacterial motility genetics at the University of Illinois, Champaign-Urbana. I had my first stint at the Jackson Lab for about a decade in the late 80s, early 90s, looking at the immunogenetics. That is, why do we reject tissues from other individuals? And we were one of the first labs in the world to really identify transplantation antigen genes. And from there, I went to the University of Illinois, the University of Louisiana, where I was on the faculty there studying the genetics of dietary-induced obesity in mouse models. And having felt that my interests span greater than what my lab was capable of, I came back to the Jackson Lab and really worked with Kathy Lutz here in setting up a Rare and Orphan Disease Center and really spending the last 6 years in getting it up and going. And happy to report on our progress and so our general sort of thinking process that we go through when we're really looking at designing new mouse models. So just for those of you who don't know, the Jackson Lab is headquartered here in Bar Harbor, Maine, but we do have sister institutions that have been set up in the last few years. One is in Genomic Medicine Institute at Farmington, Connecticut, and that's on the lower right-hand side there. And we also have facilities in Beijing, in Shanghai, in China for animal distribution, model generation, and also in Ellsworth, where we've really trying to move the bulk of our mouse distribution so that we're a little bit closer to the interstate and a little bit less of a delay in folks getting hold of mice. So as well as selling mice, the Jackson Lab is also a research institution that is independently funded through NIH and other institutions. And the mission of the lab as a whole is quite bold, and that is to discover precise genomic solutions for disease and to empower the global biomedical community in the shared quest to improve human health. And so what does the mouse have to do with people, you may ask? And the mouse as a research tool has really been around for almost 100 years now. Having been set up at the Jackson Lab in the 1930s, it was fairly evident from an early time point that a lot of the diseases that occur in human populations also occur in mice. And so part of that is, if we snap back to today and now look backwards, we know that 99% of the genes are shared between human and mouse. So if you remove the whiskers, the ears, the tail, you really end up with a small human. And that allows us to really take advantage of the ability of mice to breed rapidly, to have a large number of progeny in their litters, and to undergo generational research, as well as able to allow us to look at organ-specific effects, developmental milestones, learning, and cognizance. So when you look at that similarity throughout the genome, when you look at genes that encode proteins, that similarity is about 85%. So there are some proteins that are quite different between mouse and human. So the mouse is not going to be the solution to every single disease, but certainly it will be the solution for the majority of the diseases. And a lot of those differences can be traced back to, what is it that the mouse and human genomes differ in? Primarily, the human genome is made up of 22 autosomes and a sex chromosome X and a sex chromosome Y. So this would be a male. A female would be have 2 X chromosomes. And the mouse has fewer chromosomes. They only have 19 autosomes, but they have the same 2 sex chromosomes. So that's not to say that there are fewer genes in the mouse than there are in a human. If you look at the human karyotype, that is the chromosome maps, you can see that the chromosomes tend to get shorter as the chromosome numbers get higher. In the mouse, they tend to be more or less about the same length. And so you can pack more genes into the longer chromosomes than you can the smaller ones. But more importantly, the mouse and human genomes are essentially mosaics of each other. And what I mean by that is if you look at chromosome 1 here on human, and then you look at the mouse equivalent location of where those genes map, you can see that some of those genes on 1 map on mouse 1, but some of them map on mouse 4. And there's a small region that maps on mouse 8. So this doesn't impact our ability to study individual genes. So long as we know where the gene maps in one species, we can predict where it maps in the other species. We also have direct genome sequence that allows us to investigate that as well. Where the study of human disease gets a little bit problematic are these mutations that can occur in the population that impact the entire genome or significant portions of a genome. So for example, Down syndrome, which although is not a rare disease, is trisomy of 21. That means there are 3 copies of 21 instead of 2. And if you actually look on the mouse, the trisomy in 21 is scattered in 3 different chromosomes. So there's a region here on mouse chromosome 17, there's a region here on mouse chromosome 16, and another region here on mouse chromosome 10. So trisomy 21 in human gives us Downs. It's a little bit harder to mimic that disease in the mice. And similarly, there is a rare disease which is called 19p monosomy, which is caused by a deletion of a significant number of genes on chromosome 19. Well, if you look in the mouse, those genes are scattered throughout 5 chromosomes. So there are equivalencies on 10 and 17, and there's also regions up here on 8 and 9 that would make it challenging to make a single mouse model that would mimic that disease. Nevertheless, the mouse continues to be a useful tool because of its ability to modify the types of mutations that we can generate in the mouse. So we can look at overexpression of a gene. That's important when we're thinking about gene therapy, where we're going to be dosing patients with viral vectors that are going to overexpress genes to some extent. You don't want the cure to be worse than the disease. We can generate gene deletions, and these have been generated now for almost 2 or 3 decades. The new thing is that we can insert clinical mutations, because the absence of a gene often gives a different biology than the presence of a specific missense mutation or a clinical mutation in the same gene. So studying its loss, although it gives us clues as to its function, it really doesn't tell us whether or not that would be a good model for the human disease. We really need to look at mice that have the same mutation that are found in patients. I've already mentioned gene therapy. There are a number of interesting and exciting approaches in progress. But we can study the disease natural history, because in the clinical setting, a lot of patients appear physicians' offices when there's a change in the expected normal behavior. We want to try to figure out what's going on before that time point. Maybe we can do an earlier intervention if we have better genetic screening capabilities. And of course, genetics is not the end and where all. The drug industry is very interested in sort of off-target use of known drugs and compounds to see whether or not they're beneficial. These mouse models are going to be useful because we can try multiple strategies all at the same time and determine what is the most effective in the mouse, communicate that information to clinicians and the pharmaceutical industry, and have them evaluate whether that efficacy of the drug in mice translates to efficacy in humans. Within the Rare and Orphan Disease Center, there are 3 big questions that folk tend to ask us. You know, what do we do? Who do we work with? And how do we pay for it? The last is a sad reflection that the technology is new, the technology is complex, and it requires a lot of resources to be able to generate mouse models. So answering the first question, what do we do? The Rare and Orphan Disease Center at the Jackson Lab brings together an extensive set of mouse resources that we have available to us, as well as an extensive number of scientists at the Jackson Lab, so that we can provide a complete and customized approach to model development. So not only mouse resources are essentially pulled from those resources that we acquire and we distribute globally, but we also have scientists that have expertise in lots and lots of different organ, tissue, developmental issues that can chime in and to make suggestions, recommendations onto how we might best be able to analyze that model. We work with the scientific community. These are classical researchers, and also with individual patient foundations. These would be the parents and the caregivers. And it's important that they have an active scientific advisory board that have both clinicians and basic scientist researchers on board. And the rationale for that is that the last thing we want to do is to expend a lot of resources generating mice that nobody's ever going to study. Although the Jackson Lab does have an extensive array of scientists that work here, we don't all work on this particular disease. We don't all have expertise on every single area of the mouse. And really what we want to do is to collaborate directly with scientists who are part of that advisory board, who would be willing to take the mouse on after we've made it, and therefore publish it and make it more available. And we at the Jackson Lab would continue to make that mouse available through our sort of resource centers. Clinicians are very important to us because they tell us what to look for. A single patient may have an array of biologies, but that doesn't necessarily mean that that's fully reflective of other patients that may have mutations in the same gene. We really want to try to understand what the entire patient community for a particular rare disease looks like. Where do these mutations map in the gene, and what is the most common of those mutations, so that we can try to generate a resource that has the most value to the most number of scientific researchers, because it's the research which is really going to drive the understanding of the disease forward. How we pay for it primarily is through either through foundations that are well funded. We can develop sponsored research agreements with them where we essentially approach it like a research project. We can do an array of different possibilities. If one thing doesn't work out, we can immediately move to secondary goals and tertiary goals, perhaps maybe making a modification of the model. So we don't just make one model and then we're done. You can actually come back in and examine why that model failed in terms of efficacy and how you might be able to improve it the next time around. We also have funding from NIH and other large grant bodies to look at either rare diseases collectively or in small part. For example, I just wrote an R24 resource grant to study peroxisome deficiency. There are multiple mutations in different genes that all affect peroxisome function. And what we want to try to do is to bring all of those resources together. The mice that have been made but are relatively hard to get, we want to bring them into JAX. But also we want to fill in the gaps with models that should be made but haven't been made, so that we drive the research community forward. We also have money to make mice from the mutant repository collection. And this is a great way. When we sell mice, there's a small amount of income which is generated. We can put that income back into the Rare and Orphan Disease Center and make new mice from mice that are sold. So it's a way of paying it forward, if you like. Researchers that buy a large number of mice, helping to offset the costs of making future mouse models. And we also have shared research agreements that we have with scientific research organizations and individuals. And this is my last big slide, and it's a little bit complex. So I'm going to go through it slowly, but in a way, this describes the arc of our research goals. So all in yellow are basically core facilities that we have available to us at the lab. And that's important because many small single principal investigator funded labs throughout the universities in this country and globally have limited access to core resources. They have to do it all by themselves, and they have to be good at doing little bits of lots of different things. We have experts that man each one of these core facilities. And so really a lot of the model development pipeline is feeding in requests and taking results from each of these cores and helping us pass it along to the next generation or to the next stage of our development. Our initial call is evidence-based. You know, what is the evidence that the particular mutation which is being reported is actually causative for the gene? We have many, many different mutations in our genome, and not all of them give rise to rare diseases or disease in general, because we have 2 copies of a gene. There are cases where a mutation might be dominant, so a single mutation might be evident, and there are other cases where mutations are recessive. We want to try to build up that because we want to try to figure out what would happen here. Let's assume that we're successful and we have a mouse. How can we maintain it? Because if we can't maintain a mouse, it's not going to be a useful resource. We talk to the foundation, we talk to the scientific advisors of the foundation, and we generate a plan for characterization. That is, if we make the mouse, who's going to study it? Where is it going to go? And what can we hope to achieve with it? Do they want us to do it? Do they have scientific advisors on board who are willing to take it on? And from that, we can come up with a model development plan, which utilizes an array of different technologies to achieve the goal that we set out. And in most cases, it's making a clinical mutation in the mouse. The important step that we have here is validation. You know, can we see evidence of changes in the biology of the mouse? What's our baseline phenotype look like? What impact does that mutation have on protein expression? What impact does it have on mRNA splicing and abundance? And these are all important things to know, because even though a model might be generated, which is a missense mutation, a single amino acid change in a protein, we can actually go over here and see, well, the consequences of that single amino acid change is a complete absence of the protein because it's unstable. That is informative because it bins us into other mutations that have the same effect. And there may be more known about the absence of a protein than about the missense. So it makes additional resources available to us. Now, in this early discussion here, if the mouse already exists, we can go ahead and import it into the Jackson lab, place it in the repository, but also feed directly into validation, so we can bypass the model development stage. And we've done this for a number of different groups. Here, and then our goal is to get to this point here where we can start thinking about distribution. We place the animal in one of our repositories here at the lab, and we're now making this free, license-free and globally available. And the hope is that this new model stimulates more research into that particular disease. An important offshoot of this pipeline is our capabilities here at the lab. We can generate additional biomarkers, clinical data. We can add to the clinical story by saying, here's what we're seeing in the mouse. Are you seeing it in your patients? And there may be tissue-specific biology which is unknown because nobody thought to look at the kidneys, or nobody thought to look at cardiovascular function directly. And so this allows us to generate more information about what that protein is doing and how the mutation is impacting the mice, and by transference, what effect that is having on the clinical population. And we've worked with a number of different foundations. This is just a list of 18. It's by no means comprehensive, but each one of these foundations, which is typically had at least a dozen and maybe more individual patients which were part of the foundation, came together and really approached us to ask us to think about making models or importing models or making resources available in order to further the study into that particular area of research. And so we really covered the whole gamut. Although I think it goes without saying that a lot of the rare diseases tend to be more neurologically impactful, primarily because it's children that are being presented first. The failure to hit developmental milestones is often an indication of a neurological anomaly. And so many of these different mutations and genes which are causative here tend to fall within the neurobiology area. And I think what that does is it allows us to build a better picture of how these proteins all interact. And it may be that through our work and through the work of other scientists in the literature, we can find connections between foundations. So we can say, well, N-gly1 is a deficiency of removal of the N-glycosylation that many proteins have. There are other rare disease foundations where there's a failure to glycosylate. There's a connection there, and therefore those foundations may actually be working for a common goal, that is how to treat collectively patients that have glycosylation defects rather than patients that have a specific defect in a specific gene. Thank you for your time. Happy to answer any questions if there are any.
Thank you very much, Dr. Zubari. I think we'll wait for questions. We have one more presenter. Kevin, would you like to introduce Suzanne?
Absolutely, and thank you to Dr. Zubari for that wonderful presentation. It was very thorough. So Suzanne is going to be coming on talking about PALS. That's Patient Airlift Services, and that's a very important resource that I think the people of Maine could definitely use. Good to get the word out.
Thank you, Kevin. Thank you, everyone, for having me. I'm so excited to introduce you guys to PALS. We've been a great resource to many rare disease communities, and our goal is just to expand and help get the word out and just help many more people in need. So I'd like to start off with a short video that we had made for our 10th anniversary gala. You can play that whenever you're ready.
Sorry, my internet decided to go super slow at the moment.
No worries. It's usually how it happens.
It was 3 days before my due date. They did an ultrasound. The doctor was like, there's some things that look a little bit off. We're noticing the long bones and the baby's arms and legs are much shorter than we would expect. And so they were talking about a form of skeletal dysplasia. And there was really little that they knew about it here in Vermont. Yeah. It was fast. He came out and Chad said, we have a baby Azrin. Because we knew that if you were going to be a boy, your name would be Azrin. They sent the scans out to lots of different hospitals, and the hospital in Delaware is the one that responded and was able to diagnose him.
When we first started going down, it's about a 7.5-hour trip if we didn't have kids. Just a straight shot, no stops. But going down with Azrin is about 12 hours at least.
And after surgery, vomiting and tears on the way home, and with his back being tender, the drive is not a fun drive.
Yeah, it's really hard. And in fact, we can't really drive with him that long because of his condition. He just can't be seated that long.
Yeah.
I think you have just a minute. We're going to do some activities. After his operation, he's in a full body cast. And you know that 8-hour car ride is just way too much to put that child through. And that's where PALS comes in.
So PALS is an incredible program. They fly us to medical care for Azrin. They're the ones that make sure that it's not a 12-hour drive. It's a 2-hour hop in a quick plane. It's an amazing pilot that cares. Always know that we can get there and we can get home without a problem.
Everything is volunteer, from fuel, the use of the plane, insurance, ramp fees, whatever comes around, PALS supplies the transportation. They line up all of this travel free of charge. We call them up and they say, great, we'll help you out.
That does not happen with commercial flights.
Yeah,
you
it
know?
doesn't happen with anything.
Yeah.
So.
You know, when we go, we're thinking about all the questions to ask the doctors. We're feeling anxious if there's any kind of procedure, and to have something fun on each end of the trip that we look forward to, and that Azrin can look forward to, and that is sort of bookends the trip, that makes it amazing. Yeah, I would say PALS is the only easy piece.
All of these people, they care about us, they care about our family, and they treat Azrin like he's the most important kid they've ever met. And it makes makes it feel super special.
It feels like family in a lot of ways.
Yeah. Let's sing somewhere over the rainbow. This is why I fly. I never knew why I flew before. This is why I fly. It's actually helping a family, you know, and PALS lets me do that. It's all about giving back. You know, the bottom line is PALS makes critical care accessible to us. You know, it makes that critical care accessible to Azra. Thankfully, you know, the one constant is that we can call PALS. So get us there. They're amazing. They really are amazing.
Thank you. Seen it so many times and I still always tear up. Okay, so I know that video did a pretty good job at explaining who PALS is, but I'd like to just, you know, kind of further emphasize we're a volunteer pilot organization, and we have over 800 volunteer pilots that utilize their own private aircraft. They pay for their own fuel, and they use their own time, making this completely free of charge for the passengers. Their passion is to fly, but they would like to do it with purpose, and you know, this gives them a great opportunity to give back. We also work with some corporate sponsors and many other commercial airlines that we can use as a backup plan. Southwest Airlines donates a certain number of vouchers to us per year that we can use for further flights that the volunteer pilots with their smaller aircrafts can't always go super far, so that's where our commercial vouchers come in. And our goal is to eliminate logistics as a barrier to the best medical care. I know that for the rare disease community specifically, you know, the best care for your rare condition or your child's rare condition isn't always at a local facility, and that, you know, there does involve some travel to different facilities all around the country just to see, you know, whatever doctor specializes in the needs that you need. And to qualify for a PALS flight, the treatment does have to be over a 2-hour drive, and the passenger does need to be somewhat ambulatory and able to climb up into a small general aviation aircraft. If, you know, the patient isn't as ambulatory and needs a staircase, we can request a pilot with, you know, with a larger jet that does have a staircase and easily accessible aircraft. And we do have one stretcher plane in our fleet that operates anywhere east of the Mississippi. We actually just flew a first ALS patient from Burlington, Vermont down to Islip, New York with the stretcher plane, and he was completely not ambulatory whatsoever. So that worked out really well. So that would be an option for some people who aren't as ambulatory as others. You can go to the next slide. And we just celebrated our 10-year anniversary in November. And when we started out, we really only flew in the Northeast region, but we're proud to say that we've been successfully expanding over the last 10 years. And now we fly more south and more west. We can fly as far south as Florida and as far west as Wisconsin. So we've been acquiring more and more volunteer pilots in these states and reaching out to different facilities also in the states to acquire patients. And this is just, you know, making us, giving us the ability to expand our resources to so many more patients in need. And, you know, since we did start out in the Northeast, you know, we do have a significant amount of patients in the Maine, Massachusetts, the New England area. So because of that, we have a lot of pilots. So flights for patients in Maine tend to be, you know, pretty easy for us to fill because they, because we have such a large pilot base in these states. And you can go on to the next slide. This is one of our patients, Hadley. She's been flying with us since she was a very little girl, as you can see. We put this slide in just to emphasize that there is you know, there's no limit to the amount of flights that you can request with PALS. We have flown Hadley on over 59 PALS flights. She has a rare type of cancer and she lives in northern Maine. She is treated at Dana-Farber in Boston, which would be, I believe, a 10-hour drive for her family from where she lives. So, you know, instead of a 10-hour drive, we're able to turn that into a 1.5 to 2 hour flight. And she has been flying with us since she was a little girl. Now she's a 17-year-old senior in high school, and she actually spoke on our virtual gala back in November, a little bit about her story. And she does still need to fly regularly to checkups, but you know, without our help, it would have just been that much more stressful for her family to go down. I think she had to go down at least once a month for her treatment, and that would have been a 10-hour car ride every single time. So we were happy to step in and help her family. And for my last slide, I would just like to say, feel free to send me a referral. I had dropped my contact information in the chat box. Our intake process is pretty simple. It just requires, again, that the patient is ambulatory enough to be able to climb aboard a small aircraft, sit upright and buckle in. We've came up with some COVID safety protocols that we put in place, and they've proven to be pretty successful. And we just ask for about 5 to 7 business days notice. A lot of work does go into these flights, so we do ask for as much time as possible. But like I said, we do have a pretty big pilot base in the Maine, Vermont, Massachusetts area. So some flights in areas where we have a lot of pilots, the turnaround is pretty quick, and we can get it done in you know, a shorter time than 5 business days. So, you know, feel free to reach out, even if you think you might not qualify. Reach out to me and we can go over it. We really do try to help really anyone we can. Also for, you know, I forgot to mention before, we do ask that there is some financial need, but like other organizations, we do not require a copy of your W-2, and we try to kind of configure everything into it. Maybe you make a decent salary, but you know, you have 4 kids, 1 with medical bills, and you know, we really do try to help as many people as we can, so we take everything into consideration. You know, I look forward to working more closely with the Maine rare disease community, and I hope that we can help anyone who needs it. So thank you so much again, Kevin, and everyone involved for giving me this opportunity to present. And yeah, I'm really honored to be a part of it.
Great, thank you, Suzanne.
You're welcome.
So Kevin, I think we've got about a little bit of time left if you want to kind of open the lines and see if anybody would like to share.
Absolutely. Thank you, Suzanne. And, you know, just putting it out there, if anyone has any questions, comments, find out what challenges you're facing in Maine, or any questions you have today for any of our speakers.
Well, I do thank everybody for joining us today, and thank you, Dr. Zubari, thank you, Suzanne, and all of you for joining. I do hope you all stay connected and become a part of the Maine Rare Action Network if you're not already, and get connected to Kevin. He's new in his role as our volunteer ambassador, and we have a lot of great things, you know, that we want to work on, specifically, you know, working towards building a coalition for a rare disease advisory council in Maine. So we can't do that without the support of the rare community in Maine. So we do encourage you guys to stay connected, get involved. One thing I wanted to mention, this fun slide I have up on my, after the call, we're going to be drawing a name from today's attendees, actually 2 names, sorry, and you could win this nice little Rare Disease Day swag bag. So hopefully good luck to you, and hopefully you'll get an email from us later today sharing that you're a winner. And we do have a closing video. I will actually, I think I'm on the wrong screen, so let me just reshare.
Hi, Kristen. I think I'd like to share since
Sure.
no one else is. So my name's Keelan. I'm 26, and last year I was diagnosed with autoimmune hepatitis, which is super rare. I went through 6 months. I was lucky. Usually for autoimmune diseases, it's like 4.5 years till you get diagnosed, and you see about 4 doctors at least. So I went through 6 months of seeing doctors and going through tests last year. I was up here at Midcoast Hospital, and no one could really figure out what was wrong with me. it came up, I had some weird blood results with some strange liver enzymes that kept getting worse and worse pretty rapidly. And, up here, they pretty much said, well, you're young, you're really healthy, think you're fine. So I went through multiple doctors saying that up here. And my mom actually works in rare diseases down at in Boston. So she forced me to go to Mass General, and there they diagnosed me within a day. So it was really great. So I went through just got an MRI, liver biopsy, and it was a pretty quick diagnosis. But typically people don't figure out that they have my disease until they're, really sick. So I was incredibly lucky to get diagnosed that quickly. And fortunate that I could get care at Mass General.
Wow. Well, thank you for sharing that. That is a common challenge amongst the rare disease community. And, I know the journey to a diagnosis can be just as frustrating, and especially, in rural areas where there aren't the big city doctors, and, they're just going to regular primary providers. We hear stories like this, like that all the time. And, that's one thing NORD's, one of NORD's primary focuses is really to work on getting a timely and accurate diagnosis for rare disease patients. It's one of our big, missions and goals here at the organization. And, we do this through various ways, but, advocacy is a big part of that as well, is to getting, legislation passed that could, help the rare disease community.
Yeah, it's really great. I mean, even going to my primary care up here, they don't really know what to do with me. So most of my care really is in Boston at this point. But yeah, really like to spread awareness about autoimmune diseases and that kind of stuff.
Great. Kevin, do you want to put in the chat one more time your email for Rand so everybody can stay? I did put it up earlier, but it might have gotten lost in all of the
Oh, no, absolutely. Everyone, we would definitely love to have all of you either get in touch with me with anything you have, or go right onto our website and sign up for the Maine Rare Action Network, so that we can get you more involved, and as future events unfold, you'll be notified, and hopefully we can all work together to come up with some brainstorming, some events, and get you all involved in a little bit of volunteerism with it.
Absolutely. And thank you again, Caitlin, for sharing. All right. I have a, does anybody else, I don't want to cut anybody else off. Does anybody else like to speak before we go to this video? Okay. All right. Well, in closing, we've got this brief video to share, and then, thank you for joining us today. And, we look forward to seeing you at future events. We're really going to be kicking it off here in Maine in 2021. So hopefully we'll see your faces again soon.
Every year on the last day of February, the National Organization for Rare Disorders joins together with others around the world to raise awareness of the challenges faced by people living with rare diseases. Achieving health equity is even more difficult for rare patients. To have equity in health means everyone has an opportunity to be as healthy as possible, regardless of social, geographic, economic, or other obstacles that may be working against them. At NORD, we appreciate your support, which allows us to work on issues like health equity and many others, and for our staff and volunteers to bring them to the forefront on Rare Disease Day.
From the volunteer state ambassadors, we would like to say thank you to all of our Rare Action Network supporters for helping us connect with rare patients and families in our state.
And thank you for allowing the Rare Action Network to raise important issues with state lawmakers on Rare Disease Day and throughout the year.
Did you know that in medical school I was told when you hear hoofbeats, think horses, not zebras? But what about the more than 25 million Americans living with a rare disease? At NORD, we are humbled to provide help and resources to our zebras and their caregivers.
NORD support allowed me to catch up on some overdue bills, including my rent. Thank you for your support, NORD, and thank you for supporting Rare Disease Day.
From all of us at NORD, thank you for your dedication to the rare disease community on Rare Disease Day and every day.
Okay, well, thank you again, everybody. Thank you, Kevin, for putting together a great event today, and we look forward to seeing you at future events. Have a great day.
Thank you.
Thank you.
Bye, thank you.